Okay girls, I'm going to go through the example now of Miss Harvey losing her marbles. So Miss Harvey, let's write that in here so we know what we're doing. Miss Harvey, bless her cotton socks, has a marble that is 0.1 of a kilogram and she drops it 2 meters. So the part A is asking you to work out the gravitational potential energy of the marble, which is nice easy, mgh. So we get mass 0.1 times gravity, which is 9.8, times the 2 meters that we're dropping it by. And when we calculate all that, we get 1.96 joules. And I didn't just do that in my head, I worked it out before. Part B, what happens to the gravitational potential energy of the marble as it drops? It is converted into, that's right, kinetic energy. So we've got EP being lost and EK being gained. And part C, what is the velocity of the marble just before it hits the ground? So we assume that all of this potential energy, all EP, is converted into EK. So we know that the total EK is 1.96 joules. And we also know that EK is equal to half times mass times velocity squared. Okay, so 1.96 is equal to a half times 0.1 times v squared. So a half of 0.1 is 0.05 times v squared. I'm going to divide both sides by 0.05 and I get 39.2 is equal to v squared, and then I'm going to take the square root of 39.2 to get my velocity. And that gives me a velocity of 6.26 meters per second, and I think we've got that to, let's give it to two significant figures, 6.3 meters per second there. Okay, so I hope you follow that, girls. Well done.